for a review of mock test number 3 on today, August 10th, 2020.
Okay, x plus y is equal to 75. The equation above relates the number of minutes x Maria spends on running each day and the number of minutes y he spends biking each day. In the equation, what does the number 75 represent?
Okay, so he's really doing two activities. I'm sorry, she is really doing two activities. So do you have a correct answer for number 1?
Yes, the correct answer is C, the total number of minutes spent running and biking each day.
That's correct. So there's two things that Maria likes to do each day for her physical workout. She likes to run and she likes to bicycle. And she likes to have 75 minutes each day to do those things for herself. It is C. Anastasia, can you also read example 2?
Which of the following is equivalent to 3 open parentheses x plus 5 close parentheses minus 6?
Okay, which expression can you say is equivalent?
I put C, 3x plus 9.
Okay, so just to catch up to you, I will distribute. And I'm quite sure that she has the correct answer based on the work that I the algebra that I wrote on the board, because 15 minus 6 is 9. All right, very good. Anastasia. Hi Ming, can you read example 3? We're going to a system of equations.
Number three, x equals y minus 3, x over 2 plus 2y equals 6. Which order pairs x, y satisfy the system of equations shown above?
All right, how would you solve a system of equations like this?
You make y by itself.
Okay, so let's. Can you explain how to do that for the first equation?
You subtract y from both sides, and
Okay.
then subtract the x.
So if we subtract y, looks like the new balance will be x minus y equals minus 3. Then you'll have minus y equals minus x minus 3.
Yes.
So what can you do next?
And then you could times it by -1, so it's y equals x plus 3.
Mm-hmm. Okay, so that's probably a useful way of expressing the first equation. What about the second equation?
Second equation, you could subtract x over 2 to both sides to get 2y by itself.
All right, so I'm going to write that. I'm going to move the x to the side, and that's really x over 2 is the same as a half x.
Yes.
So then it will become...
You could divide by 2, which equals to x over 4 plus 3.
All right, so now equations are both in slope-intercept form. All right. Yeah, I like working in slope-intercept form too. When I was in high school, my teacher, that was the most common way to organize the equations. What can you do now to find the intersection for these two equations, now that they're both equal to y?
You could try just plugging in the numbers in.
Okay, so maybe let's go to the first equation because that looks easier to work with. That one has a fraction and pluses and minuses. So I will erase this here. Just write the equation in that box up here. So it's y equals x plus 3. Okay, so that's the first equation here, just rewritten in slope-intercept form. All right, so plugging in, we'll get y equals -3 plus 3, y equals 0 plus 3, y equals 6 plus 3, and y equals 36 plus 3. So I'm just setting it up for you. Which ones can we eliminate? Which ones are still good answers after we go through equation 1, and which ones can we eliminate?
We could eliminate C and D because they don't equal to -3 or -6.
All right, there it is. This would be right, 9. -3 is not 9. Oh, where'd it go? -3 is not 9, and -6 is not 39. So that's not a match. So what about A and B? A and B are true still. So let's go try those ones in with equation 2. So the ones that are still standing after that test are A and B. A was -3, 0, and B was 0, 3. All right, so using the plug-in method, what do we do next now that we still have two to go?
We could plug it in for the other equation. So -3 over 4 plus 3. And y equals 0 plus 3.
All right, so here, what happens with now that we plug it in using equation 2 for testing with equation 2?
You find that B is more is the right answer.
All right, so when we plug into equation 1, A and B survive that process. So then we move the same thing, we'll plug into equation 2. And like Haiming Chen just said, that's B. A is no good now because it's not the right location. It's not part of that line. It doesn't belong with that group. The equation or the group of points that satisfy x over 2 plus 2y equals 6. Okay, so it turns out that B is correct. So I'll cross off A. And done. All right, very good. So that is a very good method start to finish. It was different than the way that I solved it. And thank you for sharing that method. That's very good. It was Haiming. Any questions for Haiming on the method that he used to solve equation 3? Okay, the board is getting crowded, so I will just I save this to slides here for number 3. Let's go to question 4. Brendan, can you read question 4? Very good.
Which of the following complex numbers is equal to 5 plus 12y minus 9i squared minus 6i for I equals square root of -1?
Okay, so how do we group like terms here when we have complex numbers, given that I equals the square root of -1, but more importantly, I guess that I squared or I times I equals -1. So based on your knowledge of the engineering or complex plane, the plane used in engineering and sciences. So that's important here because there is a squared I term here. So can you help simplify these four terms, Brendan?
It would become minus, open parentheses, -9 minus 6i.
All right, so it will be, can you also distribute the negative into the last two terms? So be careful when those signs switch.
It would be 5 plus 12i plus 9 plus 6i.
All right, so that's correct. And then grouping like terms.
14 plus 18i.
Okay, 5 plus 9 is 14. And then the I terms are added separately, the real and the imaginary parts. So which answer is it?
D.
Answer D is correct. Sorry, I'm just coloring each one so you can see it. That's the correct total of 5 plus 9, the real part and the imaginary part for that complex number. All right, good job. That was question 4. So for the students here, there are also some 10th grade students who took the PSAT and they're taking this class. If you haven't had complex numbers, that was because of something that you have learned so far. Those are numbers that aren't expressed on the XY plane. So if we have a parabola and we have the roots are here, those are real numbers. But say if the parabola does not touch down, has no relationship to this line, the x-axis, that's when the solutions actually do exist, but in a complex plane. So if we have x and y are, there are solutions to the zero values, but they're not real numbers, as an introduction to that idea. Right, continuing with question 5. Brendan, can you also read question 5, another quadratic or a quadratic equation?
If f of x equals x squared minus 6x plus 3 divided by x minus 1, what is f of -1?
Okay, so how would you solve question 5?
You will plug in -1 for x.
All right, what's the numerator when you plug in -1, and then what's the denominator?
Be 10 divided by -2.
It is. What is 10 divided by -2?
-5.
And the correct answer, A, B, C, or D?
A.
And A is correct. All right, good job on number 5. Jaden, can you read question 6?
A company that makes wildlife video purchases camera equipment for $32,400. The equipment depreciates in value at a constant rate for 12 years, after which it is considered to have no monetary value. How much is the camera equipment worth 4 years after it is purchased?
So depreciates means that the camera equipment is less valuable. So it would be subtracted from the amount. So if I write the value, well, that started at 32,400, but then every year it's minus some dollar amount per year. So that's what I construct in my head. That's the linear equation, the starting amount minus some amount per year. So can you tell me, Jaden, What can we write for per year for this paragraph for number 6?
2,700.
2,700? Oh, that would be the per year?
Yes.
All right. Let's solve it this. Let's write it this way. How did you get that? How did you get that it must be minus 2,700? Can you explain how you got the slope?
I did $32,400 divided by 12.
Yeah, so to get the per, you find the unit rate. So 32,400 divided by 12, that's equal to, I don't have a calculator here, so 16,200 divided by 6, they're still even. 8,100 divided by 3. Then 81 divided by 3 is 2,700, and I'm pretty sure that that is the correct amount per year. So I'll write down the value, V equals it starts at 3,200, then minus that amount each year X. But X is 4, so how do we solve this?
$32,400 minus 2,700 times 4.
And what did you get for your final answer when you plugged it into the equation?
C.
And C is correct, 21,600. We went with the slope term, which is placed second here, like so. So if you're like Hyman, you're like, well, you know, I understand that it's the same thing, but you might want to write it as the slope term first, and then the y-intercept term second. That'd be the starting value. It's the same thing. Okay, very good. All right, Jaden, can you also read question 7, which was algebra? It was a technique from class called completing the square.
The following is equivalent to the expression above, x squared plus 6x plus 4.
All right, so how can you solve question 7, given that it's multiple choice? Do you remember how you solved this one?
Just simplify each choice into the standard form.
Okay, so there's absolutely nothing wrong with using FOIL. So can you explain what happened when you used FOIL on A, B, C, and D?
Got B.
So we'll just go over your correct answer. Can you use FOIL on B? And then we'll explain why that's the correct match with the equation above.
X plus 3 squared will equal to x squared plus 6x plus 9 minus 5.
And then what's 9 minus 5?
4.
9 minus 5 is 4. So you can see right away, I know he did it right. I know that he has the right last term. And all 3 terms, the number of squares, there's 1 square. 6x is the middle term. And then the last term works out to be 4. So we now got the right answer. All right, any question on Jaden's method? Jaden says, well, use FOIL. And you'll find that only one of the equations is the same 3 terms as the one above. Right. Because other students that is a practical and good way to solve it in less than a minute. Really just go right to work, be like, okay, it's one of these guys, and then just use FOIL. I'm going to explain completing the square method because other students who work with algebra and like to solve only with algebra, and I'll be your host here and explain how to isolate and then complete a square. So it's like in reverse. So the factoring skill here is well, we're given that it's x squared plus 6x plus 4. So what I'm going to do is I'm just going to move that 4 away from the trinomial that I'm about to create. And now it's x squared plus 6x plus some mystery number. Well, that number is always a half of the b term squared. So the number that I'm going to place to complete this square down here will be half of b squared. So b is 6. So I'm going to take 6 and take half of that is 3 and square it. So I have to add 9 units to complete the square. Okay, so that 9 doesn't come from nowhere. So make sure that to keep balance outside the parentheses, we also do minus 9. All right, so just to recap, if you've had these lessons in class, a is it's 1 square, so we don't have to left factor. Just put parentheses around the a and b terms. To find c, take half of b and square it. Now we have a perfect square that we can pack up. So the square is now complete. So I'll highlight that. That's ready to be packed up into a completed square. No. The square is now complete. So now it's x plus 3 squared. And we have 4 minus 9, so that'll be minus 5. And we have the same answer that Jaden had just said. We have x minus 3 squared minus 5. And that's it. We're done. All right, for question 9. Benjamin, can you turn your mic on and read question 9? Benjamin, can you turn your mic on? Justina, can you read question 8?
Ken is working this summer as a part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves 90% of his earnings
For a review of mock test number 3 on today,
hours
August 10th, 2020.
the rest of the week to save at least $270 for the week.
All right, so what's wanted here is this sort of inequality is how I start to write my equation. He gets paid at $8 for a certain amount, and that's a certain amount of earnings, plus his $10 pay rate. And together he wants to save at least $270. Actually, we have to block that off because we have to do 90% of that total paycheck. And that'll be his total savings. So, right, 90% in the front. So, Justina, were you able to get this one? Ken's total savings and the amount of hours he has to go if he wants this number of savings for the week?
Well, you already know that he has $80 because he worked 10 hours when he had an $8 rate, and he's trying to save at least $270. So that's your total.
Mm-hmm.
So you subtract 80 from both sides and then divide by 10, and you get.
Okay. So you almost got it, but there is an extra step on this SAT question. He's only able to, he's got like 10% that goes to bills or food or something. He's got a summer job on crew. So maybe they give him free housing because he works on a farm. Depends if you're a migrant farmer, sometimes you can stay in a cabin and they'll even feed you. So you're very little expenses. So he's able to save all of his money when he works. Because they might cook and they might farm together, so they cook the food together, and they can sleep in the barn or whatever, or in a cabin. He's on the farm crew, so almost all of his money he can save, but it's only 90% of it. So how do we adjust for this 90%, Justina?
We either divide or distribute it.
Yeah, what would you like to do?
I can divide.
Yeah, dividing looks good because I see that 9 times 3 is 27. Let's see what happens there.
Well, the total changes to 300.
Yeah, so now the right side's 300, right?
Mm-hmm.
So then we have 80 plus 10H, more hours working on the farm. But he wants at least $300 when he saves. So what do we do next?
Subtract the 80.
Now subtract the 80, yeah.
And then divide by 10.
10H equals, what's 300 minus 80?
220.
$220 more to earn. And what's the correct answer?
22 hours.
Yeah, so then dividing by 10 would be 20. Is that A, B, C, or D?
C.
Remember, it is greater than or equal to. So if he works on the farm, he can work 22 more hours at that farm, and he will have that much savings. Yeah, so as a summer job, I mean, I didn't do this when I was a teenager, but if you live sort of on the outside of a city and you're not far from farms, sometimes your mom and dad can like drive you. You can work all day on the farm and even have lunch or whatever there, and you can save almost all of your earnings. Or if you, and sometimes they do give housing and stuff like that. First $8 for the first 10 hours, $10 per hour after. And the extra SAT step here was the 90% times that formula. All right, thank you, Justina, on reading number 8. So that was the tricky step. If you got tricked on that, you might have chosen, I don't know, one of the other answers if you forgot to put the 90% multiplier. All right, Justina, can you also read number 9, which now is not Maria, it's Marissa.
Marissa needs to hire at least 10 staff members for an upcoming project. The staff members will be made of junior directors who are paid $640 per week and senior directors who will be paid $880 per week. Her budget for paying the staff members is no more than $9,700 per week. She must hire at least 7 junior directors and at least 1 senior director. Which of the following systems of inequalities represents the conditions described if X equals the number of junior directors and Y is the senior directors?
All right. So again, this is a tough word problem to read. So I would highlight, like if I was highlighting like in an ELA, I'd see those facts and then the variable facts. And then I'd probably, what else stands out? 9,700 per week. So I think that's related to the sum of the juniors and seniors. And then I would try to puzzle out the rest. Justina, can you explain the correct answer for number 9?
The
Based
correct
on,
answer
yeah.
is B, and it's because the first inequality has the correct values for each of the directors, and it also has the right sign for the amount of money that needs to be paid per week. The second inequality has the right amount of total, right? The right total for the directors combined, and then the third and the fourth is the right value, the right amount of directors for the specific level.
Mm-hmm. Oh, good. So then those are correct. At least 10. So the arrow's in the right direction. Hold on. You said those are the correct variables. So she's a human resources person. She decides who works at the company, which staff members will work on the new project, and she will only pay that group up to 9,700. So that's the right arrow. Wants at least 10 per people on the project, and also at least 3 juniors and at least 1 senior. So those are the right arrow directions. All right, so just as Yusina said, all 4 of those conditions have the arrows in the right direction. For Marissa hiring for this upcoming company project. Right, very good. Ethan, can you read number 10, a cubic equation?
In the equation above, a, b, c, and d are constants. If the equation has roots -1, -3, and 5, which of the following is a factor of ax cubed plus bx squared plus cx plus d?
All right, as a quick review of the idea of roots in factored form, we have x minus 3 times x minus 4 has these roots, 3 and 4. It's always the opposite sign. But that's because if I plug in 3 or 4, it'll make 0. Right? So I'll highlight it here in green. You should be able to see this or start to visualize this. 3, if I plug it into the first factor, then the first factor is now 0 because 3 minus 3 is 0. But in blue, there's another solution. 4 will work for this equation because if I throw 4 in here for the second factor, it'll make the second factor 0 and the product will be 0. So those are both good solutions for the numbers that belong here or here. And those are the two roots. So how can we use this knowledge of roots on a cubic? Well, remember I said it's the opposite sign. So based on what's given Ethan, what numbers go on these blank lines based on these roots? Ethan?
1, 3, and -5.
Oh, snap. Yeah, hold on. Let me change the color. So we now have different roots, but they belong here. And this would be the factored form, opposite sign. And here we go. And there we have it. That would be the factored form. So this is the first factor, that's the second factor, and the third factor. So of the answer choices, are any of them a match? Are any of these factors 1, 2, or 3? Ethan?
The first one matches with B.
Yeah, B is the correct answer because of these three factors, that would be the factored form of the cubic. That would be B. All right, this is worth going over because they use it more and more often on the SAT. So what I'm going to do is I'm actually going to graph this with Desmos for you so that you don't forget. So I'm going to let's take a timeout. I'm going to go to the website and just type in +1 + 3 - 5. So here we go. All right, so here's the cubic graph. It has 2 turns. And more importantly, if I hover over the graph, you can see that those are the 0 values or roots. -3, -1, and 5 because they're the opposite signs. We could also write this in a standard form. Well, I guess I'll have to do it one step at a time. So if I multiply the first 2 factors, then this is the exact same equation. All I did was I did FOIL. I took the first factor and the second factor, I multiplied it. So that's this blue line. Every single point is the same, and the roots are the same. If I hover over them, -3, -1, and 5, and done. If I want it in standard form, which we didn't have to do for this problem, but since you want to master this, even if it's a cubic on the SAT, now I have to multiply these together. So that would be x cubed plus 4x squared plus 3x. And since I'm then multiplying by -5, I can just use the idea of columns. So now I'll start with the square, then -20x minus 15. So then I just add cubes, squares, x terms, and constants. But as you can see, since it's 1 power level less, they'll line up like that. So you can definitely use the column method because they'll shift by 1. And then this will be the cubic. So I figure if I did the math right, and I type that equation in here, x cubed minus 9x squared minus 17 minus 15, I should get the exact same line traced over. And it looks like I did something wrong because that's a plus 4x. Okay, can everyone see that? So now I know I did it right. It's traced right over it. But what's the point? The point is that each form is useful. In standard form, see the green line? It immediately tells me where the y-intercept is. At -15, that's the last number, right? So in terms of behavior, if we have a camera on this particle when we turn the camera on, it's actually going to go down to this unit, wherever that is on the map, and then it'll start to accelerate up like a rocket ship, right? So that tells us that it starts at -15. We can't really see that here unless we're clever. You could just like multiply the end terms, the constants. 1 times 3 is 3 times -5. So often, although it's not told by your teachers, factored form is really useful because you can see where it has a relationship with this streamline, this x-axis. Like this is an infinite storyline for you. Well, this character here, this cubic, we first encounter it at -3, then we encounter it at -1, and it goes on its own way. Then it comes back, and then it's at the 0 line at 5. Okay, so that's the analogy. So when you're reading this in the math section, don't get confused. Say, oh, okay, these are the factors. Well, these are important points. These are all the zeros, or which you can see with the factors. And they're exactly the same. They're related to this form. If we plug in those numbers into the green line as well, we'll get a 0 value for y. Okay, on the SAT, they usually don't do equations that have more than 3 factors, like three values for the variable that will create a root or 0. Another complicated question was question 11. Charlize, can you read question 11?
The expression x to the -2 times y to the half over x to the 1/3 times y to the -1st, where x is greater than 1 and y is greater than 1, is
right.
equivalent to which of the following?
All right, so when you're dividing fractions, the rule is subtract. If I say that, can you go and solve this equation? If I copy it here, we're going to subtract the exponents. So Charlize, how would you solve question 11?
So since x to the power of -2, I brought it I put it as a denominator, so I changed it as x to the second.
All right, hold on. I'm going to erase what I just said. You had a totally different strategy, so I'm going to erase what I just said. So you said take the -2, move it down to the denominator, and make it x to the +2. So now you have x squared times x to the 1/3. Now there's only, up here, there's y to the half and y to the -1. What did you do next?
Bring the y to the -1st to the numerator.
So you can switch sides again to switch the sign of the exponent. Very smart. So you have y to the half times y to the +1. Now we have x to the 3rd, x squared. All right, so I'll highlight those in 2 different colors. All right, so you took x to the -2, you moved it down to the other side, and now it's positive. Then you did the same thing, very smart, with the other negative, and you moved it here and made it positive on this side. All right, what do you do next? What do you do next?
For y to the 1st, since it's y to the 1st, you could just make it equal to y.
Okay.
And then for y to the half, that's the same thing as saying the square root of y.
All right, so then you knew what nth roots were. So the half power is the square root. So now the numerator is square root y times y. And what's the denominator?
X to this x squared stays the same, and x to the 1/3 equals to the cube root of x.
Okay. So we have the cube root of x. And that's x squared. And that would be the simplified version. Is that a match with any of the answer choices? Is it the
Yes,
same? Which one?
D.
So Charlize is saying that that's D. So I have to check if all the pieces are the same. Well, I see y is actually the first piece, and then square root y is the second factor, and then x squared is the second factor, and that is a little 3. That is the cube root of x. Comes after x squared. Very good. So that's perfect. So D was correct. That's a simplified, an equivalent expression. It was sorted with y variables in the numerator and the x variables in the denominator. Very good. All right, any questions on number 11? Okay, question 12. Sophie, can you read question 12?
Yeah. So a function f is defined by f of x equals x plus 3 and x plus 1. The graph of f in the xy plane is a parabola. Which of the following intervals contains the x-coordinate of the vertex of the graph f?
Or what's the vertex of a graph? Can you tell the class what is that?
The vertex of a graph is the the center point between the.
It's the center point between, like, what do you mean by that?
It's in the center of the parabola.
Okay, so the parabola has a symmetry.
Yeah.
So how do we know? How do we know if it's up like a cup or if it's down like a frown? How do we know? How do we know if it's cupped up or down based on the formula that's given?
We.
Do you remember the difference between x squared, like plus bx plus c, and negative x squared? Which one was up and which one was down?
When it's up, the x is positive.
Right. And when it's down, then the x is negative. So which way will this parabola turn? Will it turn, is it up or down, the shape?
It's up.
All right, so in between these 2 points, since these points are the roots, I'll just draw it in blue here. It must be like this. That must be the basic shape. Right? It must be coming this way. It must turn around here. But the vertex is the center line, so we'll star that. That's the turnaround point. It's the middle of the parabola, which has a symmetry here. So how does that help us solve this equation?
So knowing the symmetry and the points in the roots, we know that -3 and -1 are the roots, so therefore the answer is B, and that'd be the interval.
Yeah, the intervals that are being mentioned of the intervals that are mentioned, -3, the x value is between -3 and 1. That's the only interval that contains the vertex. If I draw in orange or in a different color, here yellow, between -4 and -3, that's this interval. So that's not correct. Between 1 and 3, that would mean that the vertex is between here and here, somewhere here, in this column, in this rectangle. But the vertex isn't in there. The vertex is in between this region. And also 3 and 4 is even further to the right. So the correct interval where the vertex point is on the map, you would be searching for the turnaround point of this vertex in between those values. In fact, we do know that it's at -2 because it's the midpoint of the roots. So you should know that from your teacher as well in your regular classrooms. You should know, oh yeah, the midpoint of the roots is where the vertex and the center is. All right, any questions? Very good, very good. Sophie, I feel like several students have not spoken yet. Shyla, can you read example 13?
Can you make it a little bigger? I can't really see it.
Okay, just a moment. Is that better?
Yeah. Which of the following expressions is equivalent to x squared minus 2x minus 5 or over x minus 3?
Okay, so did you learn polynomial division? That's also from Algebra 2 class.
Yes.
So how can you solve this one? What can you do to solve question 13?
Like when you do polynomial division, it's like
It's like long division, right?
yeah.
We can do synthetic division. We can do it like long division, like x squared minus 2x minus 5 over x minus 3. All right, so one of these expressions is the same. How do we get the first value on the quotient bar? What times what is x squared?
X.
Has to be x because we're going to, just like in when we do regular division, we have x squared. We'll subtract that. But also, what's x times minus 3?
-3.
Okay. Square minus square, go away, go away. Minus 2x minus 3x is, what's minus 2x plus 3x because of the double negative?
-5x.
No, we're subtracting it. So since we're subtracting -3x, so what's minus 2x? Yeah, it's going to be, right, it's going to change it to a plus. So it'll be plus x, bring down the next term. And then what comes next for the quotient?
+1.
1. So then
Yeah.
when what's 1 times, yeah. Go ahead, can you continue?
Positive 1x minus 3, and then -5 minus -3 is -2.
-5 minus -3 is -5 plus 3, which is -2. Now you got it. And then since this is really the denominator as a remainder, that's why we have this unusual answer. The remainder is that added extra amount, but it's out of whatever we're dividing by, which is x minus 3. So then is it A, B, C, or D?
It's D.
It's D is correct. Very good. Okay. All right. I'm going to stay with, is this Talia? Talia, is this you speaking? Talia, you're still there, or is it Shyla?
Oh, it's Shyla.
Shyla? Let's stay with you just with number 13. I'm going to show you a clever shortcut because anyone in any grade can do this. It's like you can always plug in, but here, because we're using exponents, let's plug in 100 and check out how easy this is if we do that. 10, excuse me. Let's plug in 10. Oops. No. All right, so Shyla, plug in the number x equals 10, and we can also solve this using algebra. So what's the numerator going to be? What's 10 squared?
100.
100 minus?
20.
Minus 5. And then what's the denominator? It'll be 10 minus?
10 minus 3.
Oh, okay. So now can you simplify the numerator and denominator? And then it's like going to be hundreds, tens, and ones.
It would be 75 over 7.
75 divided by 7. Okay. So then we have to look at the expressions, and in saving time, we'll just make sure that 75 over 7 is exactly what happens when we plug in 10 into equation D. So can you please do that for me? Can you plug in x equals 10 again? And we'll get this, 10 plus this thing minus 2 over 10 minus 3. Okay, can you simplify this?
Be 11 minus 2 over 7.
All right, so what is, as a mixed number, 11 minus 2 sevenths?
75 over 7.
No, sorry, as a mixed number, that's 10 and how many extra pieces? 10 and 11 minus 2 sevenths is 10 and...
What?
All right, what did you do? Did you change this to 77 over 7? Is that what you did?
I just made it 75 over 7.
Okay, this is 77. I got to catch up to you. This is 11. Yeah, 11.
6 over 7 minus 2 over 7.
Yeah, because I didn't understand what you did. It's 75 over 7. Is that the same fraction?
Yeah.
Yeah, so that's a great way to, as a shortcut. It really works well with 10 in terms of computing it because you'll just get something in the hundreds when you use squares. So just like the question be hundreds, tens, and ones, right? But you be careful with the pluses and minuses. So 100 minus 20 is 80. Minus another 5, it'll just be 70. It's easy math to do. So as a shortcut on these SAT questions, especially if you haven't had Algebra 2, just plug in 10. That often works in these questions. And there's a really classic example where 10 is a good number to plug in. Okay, so if you're stumped, just plug in x equals 10. It's a little bit extra work to plug it into the expressions, but it was definitely D. Okay, and you'll see that's the correct answer. All right, thank you, Shyla, and very good. Oops. Let's go to the next problem. Charlize, did you read today?
Yeah, I did.
Okay, I think Talia didn't read actually then. Talia, can you read number 14? Hello? Talia, does your mic work? She's shaking me off. No. Ruth, can you read question 14?
A shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width x in inches of the box?
Okay, kind of unusual restrictions on the box. But I just quickly drew the facts on the that we're given. The height is 60. The width is, I'll just write as W. But they used X, so I'm going to change that W right now to an X. And I'll use X. And so it's really, these are really the dimensions of the box. This is the base, would be X by 2.5X. Okay, so how can you solve for the allowable width if they unusually say it's not the volume? They use a different formula. How do we do this? So how can we do this, Ruth? Perimeter of the base plus the height is less than or equal to 130. What's an expression for the perimeter of the base of the box? Here, I'll do this with you. So I'm going to take a red arrow. That's 2.5. That's 2.5. What's 2.5 plus 2.5?
5.
5x plus another x plus another x. What's 5x plus 2x?
7x.
Yeah, so the length is 5x total plus 2x plus the height of 60. All that together has to be less than or equal to 130. So how do we solve for x?
Subtract 60.
7x is less than or equal to, what's 130 minus 60?
70.
Yes, it is, Ruth. And what's the last step?
And divide.
Divide by 10. Yeah, x is less than or equal to 7. So which of the answers make sense if x has a limit of being 7 for those for the base value?
Isn't it 10?
Oh, snap, 10. Yeah. So is it A, B, C, or D?
A.
Has to be A. Okay, hold on. So x has to be less than or equal to 10. And the box can't have, here I'll make a little corner piece, little cornerstone. The box is not going to have 0 volume. But it is based on these linear measurements, the length, width, and height. Summed in an unusual way. So the perimeter of the base and then the height and like the column height. So that was number 14. It won't have no volume, or we won't have because it has to, when you're shipping something, it has to have some volume. Okay. All right, so one more. Looks like we can finish the multiple choice today, but I thought that these multiple choices were a little more difficult than the other 2 mock tests with the cubics and a couple of the other exponent problems. So last one for today will be number 15. And then as we're making these online lessons, still trying to make sure that you get these videos online will be posted, I promise. I'm just trying to get them online here at Chang Learning. Last one for today will be question 15. And Just one moment, please. Talia, are you back? Could you read this? Destin, can you read number 15, which is the last, usually most difficult multiple choice, is factoring.
The expression 1/3 x squared minus 2 can be rewritten as 1/3 parentheses x minus k parentheses x plus k, where k is a positive constant. What is the value of k?
Okay, so what I see is that 1/3 is standing on the left. So that means that it's been factored from the first part and the second part. So it really is 1/3 has been moved away from x squared. But working backwards, I know that it's -6 because a third, if I bring the third back in, then a third times 6 is the only number that would make 2. So I'm doing the first step for Destin here. And then, if we know that this is equal to the conjugate pattern, that means we want the square root of the first term and the square root of the second term, with a plus and a minus. So Destin, because this is from Algebra 2, I'm just going to color it in for you. Hold on just a moment. So we're going to take the square root of this. We're going to put that first. So Destin, what is the square root of x squared?
X.
Just plain old x. So I'll write that in black. That is correct. So that will be the start of each of the factors. And then what's the square root of 6?
Radical 6.
Radical 6. So I'll put that in this as a second into both places. So that's the pattern that you should know by heart for as an SAT student. So the 6 goes in as the second piece with the plus or minus in between. Now, they just write it in a strange way. They said, so hold on just a second. They say that it's a third. Well, the third is right there. But then they say this is the first factor, x minus k, and then x plus k. So I guess they put it in the other order. But what's this k value? Is it A, B, C, or D? Destin? What's the k value? The k value would be
It's D.
Is D. That's right. So this was about knowing your factoring patterns, and this one is called the conjugate. And D was the shortcut here was knowing your factor patterns. So as you work towards and as you learn more and more in high school, ladies and gentlemen, that's our review that's all we have time for now for section 3. And as promised, I'm working on the feedback and also these videos so that you too have step-by-step solutions to your SAT practice as you work towards higher and higher scores. So have a good afternoon and don't give up. Remember, as I said, no matter what grade level you're in and where you're at in your learning as of today, just classify them. Be like, okay, I'm starting to get the algebra, but not the algebra 2 questions or the geometry, and just make a list of those weak areas so you can get those 10-point questions too. All right, so have a good afternoon, and I'll see you next time. I'll see you tomorrow for our next lesson. Okay, have a good one, guys. Happy Monday.